Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.fm radio. It is another Friday evening. This one is May the 24th. 2019, 9 o'clock in the evening for those of us in the eastern portion of North America. Also known, Universal Time is 1 o'clock in the morning, May the 25th, Saturday morning, again, 2019. So that means we're live for the next hour, and of course we all invite you to come join us in our Astronomy.fm chat room, which you go to Astronomy.fm and you'll see where it says there at the bottom. Join us in the chat room during our live presentation like that. Right now, we try to keep in track of the conversation. If you have any questions for us, feel free to ask them.
And if you're listening to it afterwards, you can go to you can go find it on my YouTube page. Just put the Event Horizon YouTube, and that should get you to my YouTube page with a bit of luck. If not, you can always send me a message via the astronomy.fm Facebook page, and I will give you a link to the complete playlist. How's about that?
All right. And we'll repeat this program every 4 hours for the next 24 hours with more programming. What do we got? Is it Comet Watch tonight?
Comet Watch? Yes, the second Comet Watch of the month, believe it or not.
Wow. You guys
we did two this month.
Crank them out. Wow.
Well, we had a good guest. We've been visiting our friends at Mount Lemmon again, in Arizona, that is.
Ah, nice.
What else? Under British Skies, we're recording a new show on Sunday, believe it or not.
All right.
How's about that?
That sounds real good.
It
Back
should
to
be.
some more brand new programming.
Oh, yes.
For a lot of our stuff here.
And, of course, the real fun was going to be September. September, we're going to do Comet Watching down the pub. Literally down the pub. So we'll have a laptop and a Wi-Fi and a dictaphone, and we're going to record Comet Watch down the pub for a good laugh. Myself, Neil, and Mary will be down there, probably joined by Mark, Mary's spouse, as well. So that should be a good giggle. And literally, we're going to do it down. We're going to have fun down the pub. Hi, Black Projects. Nice to see you here.
Mm-hmm.
But yeah, we've been promising this. I was supposed to have done it last year when I went back for a couple of weeks. Well, I got sick. I got the lurgy, the dreaded lurgy, and even Sir Nelly Seagun couldn't fix it. So neither could Major Bloodknot. So of course, the chat sound is very loud. Ooh, wonder why.
Oh, sorry, that was me. I left the speaker on.
Marty.
Off now.
Anyway, so in the chat room tonight, there's myself, there's you, Marty, Glenn, Andrew, Starstorm, Black Projects, and Tor BJ. Welcome to the chat room, guys. It's nice to have you. If you are listening live, do come to the chat room. It is a very, very simple web address. It's astronomy.fm.
/chat.
It's chat, yes. Is that now, we just had a message from, let me just pull this message up. I was trying to see, but no, it's a small, little handheld one with about 4 microphone heads on it, believe it or not. It will save about a gig's worth of sound, and then I'll just convert it to an MP3 with Audacity and upload it as usual to either Michael or Rob for a little bit of polishing, and you'll probably hear some extraneous noises, lots of chattering and glasses in the background, I'm sure. Maybe even the odd bit of wildlife. Who knows?
Now, this is Astronomy in the Pub, right? Is this a quiet pub you go to, or is this a noisy pub?
I don't know what it's like anymore. I haven't been down that pub in the last at least 4 years. I haven't decided which pub we're going to use either.
Mm-hmm.
It might be the Checkers in Hall End. It might be the Cross Keys in Wood End. So I've only got to walk about. Oh,
Are you going to make this a video event?
we could possibly do it as a video. That means everybody would be clustering around my laptop.
Mm-hmm.
Do it, but is that possibility? I'll see what my co-hosts say.
You can always get an external camera.
Yeah,
might be a little easier.
Either that. We should do the show as a video one of these days, Marty.
Yeah, we should someday.
Yeah, definitely before I go back, so I've got the bandwidth.
Mm-hmm.
But yeah, it'll be interesting. It's good fun to get out and socialise, and I am looking forward to, hopefully, touch wood, getting to European Astrofest next February. I wonder if they still keep the name after Brexit. Who knows? But anyway, getting there. I've been told that he's going to have an interesting guest list already. Maybe I'll do a couple of lectures. I don't know. But I'm probably going to try and meet up with Black Projects, Paul Harper, and some of the regular gang. And we'll see what happens.
Yep. Is this going to be a permanent or temporary move back to the UK?
Well, we'll have to wait and see on that one.
Okay.
Would you like me to collect the links that have been put in?
Please do, Mariah. Okay. So anyway, we've got 2 links in the chat room already. One from Glenn, and we have got one from Black Projects. And Black Projects is talking about Starlink, and Glenn's talking about water on the moon's surface, lunar regolith. I'm just going to pop that up a second.
Let's talk about Starlink.
Okay, we'll do Starlink first.
Starlink first, which just launched a couple days ago. A Falcon 9 rocket, if I'm not mistaken, launched 60 little satellites to be part of a constellation for internet, if I recall.
Yep.
And you had a picture that you put in our chat. I saw that.
I put the high-res YouTube version in.
Okay.
That I discovered, and it shows the actual trail of the satellites going over the Netherlands.
Here's a link to the launch. If you didn't see it before, you can see it on their webcast. It's been recorded, so it was a pretty good launch. Cheers at every time something happened positively, like main engine cut off and the second stage reigniting and separation and stuff like that. So it was all in all a pretty good launch. The booster returned in a different way. It went purposely too far, partially into orbit. So they basically could not land the booster back where they launched from. So they put a catch platform out in the Atlantic Ocean for it to land onto. So couldn't go back as far, but it could come down to where they had the landing platform floating out in the oceans. And then you posted a picture of part of the deployment. Have you ever seen?
I posted on YouTube. Yeah.
Yep. I'll post it in our chat room here. So, was that in there? You did that right. Okay, got it.
I've done that. We're ahead of you there, Martin.
The one from YouTube. Gotcha.
This is the high-res version.
Okay. Yeah, if you get a chance to go look up how those satellites were laid in that payload compartment, the top of the rocket, it's actually pretty cool. It's like racks and racks of satellites and not real big. And you could actually see in the launch video how the shroud separated away when it was supposed to, and you could see that rack of satellites in space before it got into the altitude orbit that they wanted.
The interesting thing is this is going, how people feel about them is going the same way as that disco ball that the New Zealanders put up, which was a bit of a damp squib.
Oh,
I
which?
don't,
Oh, that. Well, yeah. What was that called? It was another star something, not Starball.
yeah,
What was it?
something like
Something.
Starbucks.
Yeah, but it was actually pretty small. That thing was only like 2 or 3 feet in diameter, so not. Even though it had little mirrors all over, it was not very reflective and difficult to see, and
And of
nothing,
course,
nothing really
people
special.
say they're as bad as Iridium.
Mm-hmm.
When the whole constellation was up there, everybody was complaining about it. They'd have a nice dark sky. They'd be imaging something nice and faint and fuzzy, and then this thing whips across your image,
Mm-hmm.
which means you got to start doing you got to reset and go back to the beginning. And
Yes,
it
but
really goes to something really deep and fuzzy and indistinct. It's a real pain because you've got to come back night after night and try to beat the Iridium satellites.
yes, but those were predictable, and I think those are still out there. So yeah, you can actually see them. They've calculated their orbits and reflectivity, so you can look them up on I think Heavens Above and see when they're actually going to flare on purpose in your area. So they're not that hard to avoid if you just do a little bit of homework. So yeah, if you're doing like a long exposure of a certain area, you really want to check the orbital positions of those satellites before you do any important photograph like that.
And of course, a lot of people are already calling the Musk ComSats vermin in the skies. So it's going to be interesting.
I don't know how bright those are going to be. It'll be interesting to see. They're pretty small.
Well, time will tell whether they're vermin or just irritation.
Mm-hmm.
But
there's lots of satellites up there, and the space station goes overhead, and that's actually pretty bright too.
Yeah.
So if you're going to do any
I don't even have to wait for it to do a visible pass. I can track it.
Radio-wise, well, if you're imaging, you pretty much want to know if it's going to go through your image at the time, though, ahead of time.
Yeah, but the thing is, because my Heavens Above app, I have the pro version, so I have all the satellites which are really going to be a pain in the whatever for me. I can track. So I've got the radio amateur satellites. I've got the major comsats, some of the military stuff that they want us to know about. Iridium's on there. I guess that means I'm going to be getting a message that I have to access Wi-Fi because they're about to dump me a big file of new updates of orbital elements. So that's going to be fun. But as I say, time will tell. Are they dealable or are they a real nightmare for imaging? So I understand the rationale behind them, but as I say, at the moment, reading some of the Twitter posts, it's the jury's out. Michael Baylor is excited about this. They're going to be the substitute for the end of the Iridium flares. Of course, they'll spread out, but the number of launches will make these events fairly frequent. What else am I seeing here?
I haven't seen the shape of any of those satellites. If you would happen to have an image of the one individual satellite, would you? Are they going to have like extended solar panels or radio panels or antennas or anything like that on them, so that they'll be much larger than their folded up size?
Let's see what we can find.
No, they show the cluster inside their cargo hold, but not what any individual one really looks like, though.
Here we go. This looks like this is a good one. Copy image address. Let's see if this works.
Okay. Where's this one from?
This one is from Digital Trends.
Okay.
Yep, it works.
It works? All right. Oh, yep. So it does have some pretty good solar panels on it. The radio is a dish, but the whole box part is really not that big. So it'd be interesting to see. I'll get some real stats on it and figure out how big they're going to be and how much they'll actually cause some flaring on the ground, stuff like that. And again, if they'll be predictable or if they're going to change positions or something like that. So I don't know. We'll find out. most satellites you can actually find the position of them, but the iridiums were the ones that were predicted. You could actually predict where they were going to shine the brightest at what time also.
Let's see what we can do on the predict on the orbital elements.
All right, let's see what else we got coming on here. Just real quick, satellite. Satellite. Asteroid. Well, this one got a little bit overhyped. Asteroid 66391 also has another designation. I can't remember what it is. So, flying by sometime today. It's a big one. 1,700 meters in diameter. No, 1,700. Yeah, 1,700 meters in diameter. But it's actually pretty far away. It's about, 3.5 million miles away from us when it passed by. So it's big, but it's really not all that close. And, some of the news, not necessarily science news agencies, were reporting this big asteroid to be flying by today. Well, yeah, it's big. It's almost a mile in diameter, but it's also 3 million miles away, and that's more than safe for that one. And that's going by sometime today. I don't think that's, I think I remember the visibility of it. It's really faint, like 18th magnitude or something like that. So big but far away, 13 and a half times as far away as the moon, and it's only about a mile. So yeah, that would make it end up being fairly faint. It'll be good for radar. Some big ones bouncing signals off it. They already know it's a double asteroid. It has a smaller companion to it, so they're calling it a moon, which is not really all that big if the asteroid's only a mile in diameter anyway. So good for researchers with big equipment, but not so much for amateur astronomers. And don't scare the public, okay, news agencies? just try to stop doing that for a little bit. But in the meantime, there has been big rocks crashing into the Earth lately. Well, 20 to 40 feet in diameter, stuff like that. Yeah, some pretty big rocks have been hitting us. Several of them have been in Australia.
Mm-hmm.
That was one of the big ones. So nice videos that caught on security cameras and things like that. So I don't know if I've got any of those images. Yeah, I think I do. If you go to American Meteor Society, amsmeteors.org, they usually put the latest video of a meteor coming down. And the ones that I've liked recently are the ones that are basically above broken clouds. Gives it a little bit more of a creepy factor to it. Oh yeah, here's one recently from, this is an older one from February down in Key West. There's another one, two of them were in Australia just like 2 days ago.
Now, something to begin to look forward to. Nucleus cloud season begins. Noctilucent has begun. The AIM spacecraft has spotted wispy patches of electric blue drifting over the Arctic Ocean. This marks the beginning of the 2019 season for NLCs. Okay, so fairly soon, northern countries will begin to see these night shining clouds with the unaided eye. So let me just get the full story and tips here.
Okay.
This 1 second.
I got to say, I don't know if I've ever seen noctilucent clouds or not, because where I live, there's so many cities that even when it's really dark and there's really high clouds, the cities light up those clouds. So it's really hard to say, because like clouds around me are always visible at nighttime. They're not like dark patches in the sky. They're bright patches in the sky. And I've been in one area, I think it was out in Vermont one time, when I was looking up around the skies, and one of the stars was missing. One of the brighter stars, like Spica or Arcturus, was just not there. And then it was there a little bit later, and I figured out, it just must have been a cloud passing in front of it. It was just really dark skies and no ground lights lighting up that cloud. It was kind of weird to see major star missing like that. So
Now,
you mostly see clouds lit up by ground lights. I don't know if I've ever seen these noctilucent clouds or not.
I think I've seen them once, many, many years ago. But that night I wasn't particularly interested in the clouds. I just had a message come through from the BAA Aurora section asking people to us all to pile outdoors and see if we could actually see any auroral activity, which I was pretty happy. I was willing to say yes, so I called back and says, I think I've seen it. And I described what I said. He says, that sounds pretty good. That's one for the books. So, yeah, I think I've seen them. I don't really pay much attention to them, really.
Mm-hmm.
I'm not really looking for the clouds. I'm looking for holes in the cloud because I'm looking to image something else.
Yep. Yeah.
But the season's beginning, so now's the time to get everything ready. Get your deck chair out, get your blanket, get your flask of tea or coffee ready, and get ready to spend the night outdoors in the garden.
So basically, these are clouds that are pretty high up. The sun has just gotten below the horizon, but there's still sunlight lighting up the clouds after the sun's below the horizon. Well, yeah, I could do that for kind of low-lying clouds, but I guess it's got to be at least like a half hour to an hour after sunset to be real noctilucent clouds, and they'll be like luminous blue-white tendrils spreading across the sky. So give it a shot. Keep looking. This is basically, for some reason, the time of year when this happens regularly. So give it a shot.
High optronics.
Look an hour after sunset towards the west and see if you can see some clouds being lit up by sunlight. Something a little bit more than just the twilight glow lighting up the clouds.
The other thing, of course, the sun is utterly and totally blank.
Yes, it is.
According to spaceweather.com, current stretch of spotless days is now at 5.
Mm-hmm.
Sunspot number is 0. X-ray solar flare 6-hour max. There was an A7 at 22:27 hours UT, and there was another 24 hours A7 starting from 06:37 hours UT. That was updated today at 2300 hours universal time. Now, the interesting thing, the thing that really got me, that I saw and that got my mind going, was an article about a future close encounter with the Taurid stream. So in November of 2032, the Earth will pass through the Taurid stream. This is a cloud of debris from Comet P2 Encke. It makes some spectacular fireballs, and when its gravelly particles interact with the Earth's atmosphere. Previous encounters with the swarm were in 2005 and 2015. It did produce some showers of bright meteors seen around the world. In 75, the swarm contacted the moon, making Apollo seismic sensors ring with evidence of objects hitting the lunar surface. So if the forecast is correct, we're in for a similar activity 22 years from now. The other thing, of course, is some researchers are thinking, well, there might be more to the Taurid swarm than just pebble-sized particles, which make lovely fireballs. Some things say that it could level a forest. Well, of course, on June 30th of 1908, a forest in Siberia did fall down when a 100-meter object fell out of the sky and exploded above the Tunguska River. They've now managed to backtrack the trajectory of the impactor. And the evidence is suggesting it may have come from the Taurid swarm. Now, why would the swarm have such big rocks? After all, comet debris is normally no bigger than specks of dust. Mm-hmm. The most popular theory that holds that 10 or 20,000 years ago, a giant 100-kilometer wide comet fragmented in the inner solar system. Now, a breakup like that would produce a mixture of dust and asteroid-sized bodies that are still present today. In fact, 2P Encke itself may just be one of the fragments. So, if the Taurid swarm does indeed contain Tunguska class impactors, we here on Earth need to know this. So, a team of astronomers from the University of Western Ontario suggests this summer is a great time to find out. In June of this year, the Earth will approach within 0.06 AU, or 93 million kilometers, of the center of the Torrid Stream. Its closest post-perihelion encounter with the Earth since 1975, according to UWO astronomers David Clark, Paul Wiggett, and Peter Brown, in a paper that's just been accepted for the publication in the monthly notice of the Royal Astronomical Society. This will be the best viewing geometry to detect and place limits on the number of near-Earth objects proposed to reside in the swarm center, at least until the early 2030s. So in other words, NASA, ESA, Roscoff, JAXA, and China, this is the time to really start getting your fingers out, because we are going to be, in about 22 years, we will be being very much into the stream, and we're probably going to need some kit by then. Okay.
and also keep an eye on the moon too during that time.
Exactly. The best time to do this, of course, is to pray and hope for either a first quarter moon or a waning moon, because the best way to see them is in part impacting in the dark shadow as it moves across the terminator.
Yep.
So what has happened is, seeing anything in the swarm is going to be tough, says Wiegand. It's faint, it's spread across a lot of sky, and it moves fast. So they need some serendipity to catch a glimpse of it. But they're going to have to try and strike when the iron is hot, and that's now. So they've now applied for 10 hours of time on the Canada, France, Hawaii telescope on Mauna Kea. And we're hoping that other big telescopes will join the search as well. So there's an original research paper listed in the spaceweather.com website to learn more about this year's encounter with the Taurids. So get stuck in. You can do good citizen science literally by just going out at night and with a little clicker and clicking every time you see one. So do have a good look at it. Get
a chart too that you could draw on and draw its trajectory.
Yeah.
Or if
even better, have a camera.
Yes, camera's better. A good way of drawing on something like that is to have a star chart covered with like plexiglass. It's its own table, and use a China marker and draw. If you can know your constellations well enough, you see a fireball, draw it on the plexiglass. Draw a track on the plexiglass that's overlaid the star chart. Then you can always erase it for the next one too.
Well, what you do, you draw it, photograph it, wipe it, go for the next one. So, of course, obviously, you're going to need to have someone who's willing to take over, because most cameras, they're going to probably push you into using flash. You're going to be blinded for about the next 20 minutes. But your partner, who is probably wearing sunglasses, isn't this reminiscent of the Men in Black or something? Can then take their sunglasses off. They can do the next observation, draw the next track, and hopefully by then you've recovered.
Yep.
Because then you can take over and do the next one.
You could also just paper print star charts of the sky for that evening, and then you could draw right on your printed star chart instead of not on your good one that you have in its own book or something like that, but copies of it.
So, as I say, there are plenty of ways to do it. Some of them are nicely Heath Robinson. I think you call him Rube Goldberg over here. But I want to hold that against you, Martin. Yeah.
It's a good group project, too. It can be done with, several people. Basically, like lay down lawn chairs. And if you put partitions between each person so that each person only sees one part of the sky, then the drawings don't overlap and the counts don't double up. So basically, whatever appears in your part of the sky, you write down, and then another person will have something going, in their part of the sky, and they'll write that down. So you're not doubling the counts by having more than one person seeing the same meteor and counting it multiple times.
So there's plenty of ways you can do it. Plenty of ways you can have fun. It's a good family event. Get the family outdoors. Have a fun night outdoors. And of course, you can have a radio going tuned to a distant station you don't normally hear, and you can try and count the pings too, as the radio signals bounce off the ion trails from these little pieces of dust and pebbles as they come screaming through the atmosphere.
Yep. Couple of meteor showers coming up. Nothing in May, but 3 of them beginning of June. We've got the Tau Herculids peaking on June the 3rd. On June 8th, 2 of them. June Mu, which I think is actually pronounced me. June Me, Cassiopeids, and Eritids on June 8th also.
And of course, it's the bottom of the hour, so you know what we're going to do. You're listening to the Event Horizon on astronomy.fm. And we have in the chat room Sky Guide Nick, Sky Guide Marty, Glenn, Andrew, Starstorm, and Uptronics.
Where the galaxy seems a bit closer.
Thank you very much, Starstorm.
The show is broadcast on May the 24th, 2019. And don't forget, more programming coming up afterwards.
Yes, a good comet watch. We went for an hour and 15 minutes, I think.
There you go.
Okay,
all right. So
let's go to Glenn's link.
Okay, what's Glenn linked us to?
Glenn has linked us to scientists have found moving water on the moon. I'll put it back into the chat room in case anybody's missed it, because the chat room does move on. And if you're coming in or just recently came in, you would have missed it. So research is definitely still going on. The moon isn't as dry as they thought. This is the message from data from LRO.
That could have been taken in another way.
Oh, you think? Anyway, the Earth's moon was once assumed to be a dry and dusty place. In fact, they thought when they first landed on the moon that the astronauts and the spacecraft were actually going to sink into the lunar surface. Of course, that's a reference to the book A Fall of Moon Dust. It was Arthur C. Clarke. Anyway, so
being logical that if the moon keeps getting hit by asteroids and rocks and stuff like that, it's going to pulverize whatever it hits, and doing that for 4 billion years, that there's the thought that, well, maybe the moon is really covered in several feet of moon dust from all that pulverization. Turns out
far from it
was just an inch or so.
Now, what it is, LRO has revealed that the water present actually moves around during lunar daytime. A study on the moisture on the moon is to be published in the Geophysical Research Letters, and it paints a vivid picture of water molecules on the surface. And NASA sums up the water's behavior as follows. Water molecules remain tightly bound to the regolith until surface temperatures peak near lunar noon. Then the molecules thermally deabsorb and can bounce to a nearby location that is cold enough for the molecule to stick or populate the moon's extremely tenuous atmosphere or exosphere until temperatures drop and the molecules return to the surface. How are they doing this? Well, they're using the Lyman Alpha mapping project. It takes readings from LRO to detect the presence of water in the regolith and allows researchers to track the movement of moisture. When you think about it, this is data that they are really going to need, and this will be very useful when planning future missions and potentially even permanent lunar settlements. And of course, looking forward, NASA and other scientific groups have discussed the potential of using the moon as a sort of jumping off point for missions deeper into space. Mars, Jupiter, Saturn.
Pick up those poor rovers.
They're getting a new friend soon.
Saturn V.
Fix them up too.
No, what was that? What was that?
Just a bit of repair and cleaning.
What was that, Marty?
Outlander? What was that? What was the name of that movie? One of the moons of one of the planets.
Oh, you mean when the space marshal on a mining colony?
Yeah.
It may have been Outlander, yeah. It starred Sean Connery as the marshal. He packs his family off the mining facility because the crooks are getting fed up with him interfering in their business.
Mm-hmm.
And of course, this won't be the first time it's been thought of. the moon as a transit point has long been a favorite in science fiction. Space 1999 springs to mind with a metaprobe in an orbit between the Earth and the moon being used for training missions for the astronauts. And as I say, I've lost track of the number of stories that do that. And of course, one of the books that really caught my attention recently was by Paul Spurdis. And it was about a lunar colony and all the trials and tribulations. And I'm just going to see if I can find that book for you.
Mm-hmm.
Paul, by the way, is actually a NASA scientist, before anybody wonders.
Okay.
And he writes fact and fiction about the moon. So, he's also he's a geologist, by the way.
Hey, lunar geology is probably a lot really interesting.
And we actually lost him last year. He's an American geologist and lunar scientist. The book was Moonwake, The Lunar Frontier. He co-wrote it with his wife. He's actually known for quite a lot of papers. Paul wrote a paper with Graham Ryder, Apollo 17, Impact Melts the Geology of the Taurus Lito Highlands, Blogging the Moon, the Once and Future Moon Collection. He was actually part of the team on the Clementine Atlas of the Moon, which now the Cambridge University print on demand. Here's a good one. The Moon, Port of Entry to cislunar space towards a theory of space power. Selected essays. Instantly published by the Institute of National Strategic Studies, National Defense University of Washington, D.C. in Chapter 12. I'll put his Wikipedia entry into the chat room.
Wikipedia isn't that reliable, though.
But the thing is, I do know about Paul, and I know these facts are fairly accurate.
Okay, that's fair enough. Confirm them.
Yeah. So, did Starstorm read in Wikipedia that Wikipedia is not that reliable? And if she did, that means that statement is not that reliable, which means Wikipedia is more reliable than it is.
For going back many years, someone was quoting Wikipedia in a chat room whose name will not be mentioned, Marty.
Oh, that's good.
And so somebody went in and altered the Wikipedia on planetary nebula. And they changed it to read planetary nebulae are created when the TARDIS materializes and moves at extreme speed through normal space-time.
That's the way to mess with somebody.
That person will never be able to post in Wikipedia again.
No, they haven't been. But the thing is, it took a fair while for somebody to notice what had been posted. The fact that the whole thing had been done, and I was okay. Well, what's the entry on planetary nebula? I looked at it. No, this isn't right, because I know I looked at it about a week ago, and this was not here. But people do mess with Wikipedia. Starstorm is quite correct, but I do know a bit about Paul's background, and I've read some of his stuff. So I guess this is an entry we can trust.
I think so. Mars 2020.
Yep. Have you got your ticket?
I've not got my ticket boarding pass yet, but yes, that is something I'm definitely going to do. Yes, you can put your name onto the Mars rover.
The link is in the chat room, folks.
Oh, great. Yeah, I did put my name on the Artemis. No, sorry, not the Artemis. Iris is the moon probe. Onto the Parker space probe.
Yes, I've got my name on there as well.
That's the first one I did, actually, so I'm going to do it on this one also. That'd be nice. And maybe, can you put more than one name on, or just one name per person, per what? Do you remember?
It's one name per entry.
Per entry, okay. So obviously we got to put some astronomy.fm names on there too.
Glenn was saying Saturn V was Kirk. That was Kirk Douglas and Farrah Fawcett Majors.
Yes, that was it. What was it called?
Saturn V.
Saturn V. I was right when I said Saturn V.
Outlander was Sean Connery.
Gotcha. That was another space moon mining mission movie, right?
Mm-hmm.
Okay.
I think I can't remember. Saturn V was one of those really, really weird movies.
Mm-hmm.
Let me come out of here, search Wikipedia.
So if they're wrong, who cares? It's just a story.
Okay, let's have if my spelling is. Okay, let's just change my spelling a bit. It's been a long day today.
Mm-hmm.
Saturn V.
Movie. Add the word movie to it. Because you'll just get a whole bunch of rocket stuff if you don't.
Oh, guess what? There is not a page for Saturn V on Wikipedia.
Oh, really? Oh, that's unusual.
Yeah.
IBDM then.
Okay.
IMD.
I'll just simply Google it.
Just Google it then. All right. You look that up, and I will. Go ahead. You ready? Because I got another article in the meantime.
Just 1 second. I'm just checking something here. Actually, it's Saturn 3.
Saturn 3. Okay. I didn't think Saturn 5 quite sounded right. Saturn 3. Gotcha.
Saturn 3. A couple of space station dwellers are menaced by a scientist and his amorous android. The robot is dismantled, but it soon finds a way of putting its parts back together in the right order and continuing its quest. It was released in May 1980 in the UK.
Okay. All right, here's the one I've got now. Let's see, make sure I get the right link here into our chat room. Osiris Rex mission that went to the asteroid Bennu. Now they're inviting the public to help the asteroid mission choose a sample site. So basically, I guess you can vote on probably several predetermined landing sites, and you can vote on which site that you think the mission should actually land on to pick up a sample of this asteroid.
Sounds fun to me.
Links in our chat room. So yes, another a little bit more of a fun citizen scientist type of thing that you can actually do.
Okay, so
it's definitely a rock pile.
Oh yeah, it's a rubble pile. Okay, so let's go to JPL, shall we, for a brief visit?
Let's go to JPL.
Okay, we'll go to JPL.
I don't know if I've ever been to JPL. No, that's California, so no, I haven't. Go ahead.
So, comet provides new clues to the origins of Earth's oceans.
Yes.
It's always been a bit of a mystery, really, why we have so much water, allowing our blue marble to support the astounding array of life it does. And it's becoming slightly clearer with some of the new research into comets. Comets are like snowballs of rock, dust, ice, and other frozen chemicals that vaporize as they get closer to the sun. It produces the tails we see in images. A new study reveals that the water in many comets may share a common origin with Earth's oceans, reinforcing the idea that comets played a key role in bringing water to our planet billions of years ago. So, Sophia, which is the world's largest airborne observatory, observed Comet Vitrin as it made its closest approach to the Earth in December of 2018. Now, the data that they collected from the observatory found that the comet actually contains ocean-like water. Now, comparing this with what we know about other comets, scientists believe that in a new study that many more comets than previously thought may have delivered water to the Earth. Well, we know that they impacted because we've seen some of the craters and stuff. Now, the thing is, they have identified a vast reservoir of Earth-like water in the outer reaches of the solar system. And this is Derek Liss, a scientist at JPL in Pasadena, California. And he's the lead author of the study. As always, for us and for any carbon-based units, water is crucial for the development of life as we know it. We not only want to understand how we got our water, but we also trying to figure out if this process could work in other planetary systems. So planets form, as we know, from debris orbiting in a disk shape around a star. Small pieces of debris can stick together and they grow larger over time. Leftover debris remains in regions of our solar systems like the Kuiper Belt, beyond Neptune, or in the Oort cloud itself, far past Pluto. Comets come from those areas, but we only see them when their orbits bring them closer to the sun. Heat from the sun causes some of this dirty snow to vaporize and it creates the fuzzy halo or coma of water vapor, dust, and ice grains that we see in our images. So they're predicting that the water on Earth came from water-bearing comets in the early solar system that collided with our planet, similar to today's ice-rich asteroids or comets. But we don't know where in the formative disk of the solar system these objects originated. Now, scientifically speaking, we know water by its chemical name, which is H2O. It's made of 2 hydrogen atoms and 1 oxygen atom. But by using special instruments, they can detect the 2 types of water: regular water, H2O, and heavy water, HDO, which has an extra neutrally charged particle called a neutron inside one of the hydrogen atoms. Another name for it would be deuterium. Now, when you compare the amounts of heavy to regular water in comets, if comets have the same ratio of these water types as Earth's oceans, it indicates that water may share a common origin. But working out this ratio is the difficult part. Ground and space telescopes can study this in detail only when they come close to the Earth. And missions like Rosetta are rare. And of course, they've only been able to study this ratio in about a dozen comets since the 1980s. And of course, it's difficult to study the water in a comet because from the ground, the water in the Earth's atmosphere blocks its signature. So what do? You can go to high altitudes, much above the Earth's atmospheric water, and it allows Sophia to accurately measure the ratio of regular to heavy water in Vitron. The data showed that comet Vitron's water ratio is about the same as the Earth's oceans. So when you compare the new Sophia data with previous studies, they found a surprising commonality. The ratio to heavy to regular to heavy water was not linked to the origin of comets, whether they came from the Oort cloud or the Kuiper belt, but instead it's directly to how much water is released from the ice grains in the coma compared directly from the snowy surface. So it could imply that all comets could have a heavy to regular water ratio similar to Earth's oceans, and they could have delivered a large fraction of the water to Earth. So this is the first time we've actually been able to relate the ratio of heavier and regular water to all comets to a single factor. According to Dominique Brockley-Morvan, scientist at the Paris Observatory and the French National Centre for Scientific Study. And he or she is also the second author of the paper. We're going to have to obviously rethink how we study comets because water released from the ice grains appears to be a better indicator of the overall water ratio than what is released from surface ice. So we need more studies to do it to find this out.
Yes.
And of course,
it's kind of gone back and forth between yes, the water came from comets. No, the water didn't come from comets. To yes, the water came from comets. Kind of back and forth as they were getting different results from different comets.
Now, of course, the other thing is Sophia is the Stratospheric Observatory for Infrared Astronomy. It is a converted Boeing 747 SP airliner modified to carry a 106-inch diameter telescope. It's a joint project between NASA, the German Aerospace Center, DLR, NASA's AIM Research Center in California's Silicon Valley, manages the Sophia program. Science and mission operations in conjunction with the University's Space Research Association, which is headquartered in Columbia, Maryland. And of course, the German Sophia Institute, DIS, at the University of Stuttgart. And of course, the aircraft is maintained and operated from NASA's Armstrong Flight Research Center, Building 703 in Palmdale, California.
The comets that Sophia's been studying, they've been finding this similar water to are called hyperactive comets. The ones that basically they're just basically round, and when they flare up and they get like a million-mile coma around them, those are the ones that they've found. I think three comets with the same type of water as on the Earth. Those are called hyperactive comets. So
go on.
Back to comets, providing water to the Earth back 4 billion years ago. Plus.
Well, as I say, it's interesting because there's still the people who are just not willing to buy the evidence.
Mm-hmm.
Scientific facts, you can show them it, but you can't make people accept it, unfortunately.
Right. Well, this is only the three comets so far that have had that right matching ratio to the Earth's water. So still some of them have it, or they don't know if the processes are slightly different with each comet, even though they might all have the same deuterium to hydrogen ratio in them.
Okay, now since we're talking telescopes and stuff, the next story I have for the show, we're doing pretty good. We got some pretty good starts going here, Marty.
Mm-hmm.
This is an ESO announcement. They have a $17 million euro fund backing 170 breakthrough concepts in imaging and sensing. This is from the European Southern Observatory. ATTRACT, which is an Horizon 2020 research and innovation project funded by the European Union and backed by a consortium of 9 partners, including the ESO, has announced 170 breakthrough ideas, which will each receive 100,000 euros to develop technologies that have the potential to change society. The selected proposals include projects which highlight the societal benefits of ESO's astronomical expertise. So they drew these projects for funding from a pool of about 1,200 proposals from researchers and entrepreneurs in science and industrial organizations across the world. An independent research and development and innovation committee used a rigorous evaluation process to determine which of these proposals would receive the funding through ESA and the European Space and the European Southern Observatory. So one of them is a 3D cancer spec, which will bring astronomical technology to bear against cancer. I'm just going through there's an image sensor for single photons. So a single photon visible light image sensors to lay the foundations for transformational changes in low light imaging.
Okay, I found it, Mommy.
And this one is actually coordinated by Konstantin Stefanova of the Open University in partnership with ESO detector specialist Mark Downing. And it aims to develop single photon visible light spectrum images suitable for adaptive optics systems and low light spectrographic and imaging applications. So plenty of astronomical potential there. I'm trying to see what else is going on. But all the information is really in the article. If we got talking about this article only, we would probably go over by about 2 hours.
Mm-hmm.
Haven't done that in a long time, have we, Marty?
We're not going to do that. We've done that once before. We're not going to do that, though. All right, I've got another article about the Mars 2020 rover. Seems that there is an area on Mars with looks like a strange mineral deposit. And it just happens to be right where they're going to land a Mars 2020 rover. They think the mineral deposit came from volcanoes in the early times of Mars. Thinking maybe these are like explosive volcanoes. That's what they had early in Mars formations, was very violent, explosive volcanoes. Later on, they were more dampered down to just kind of like oozing, flowing type of volcanoes. But maybe early on, they had some, pretty wild, explosive volcanoes.
Well,
one thing I think is pretty cool is when they analyze, this material when they get there, is they'll be able to tell by the material, its size, how it traveled away from the volcano, and they'll also be able, with this information, they'll be able to determine, for instance, how thick the atmosphere of Mars was by analyzing these particles and how they've moved when the volcano erupted, basically. So it's interesting that you can determine different things by studying one type of object. It'd be kind of cool to see, okay, this type of particle, the size of particle drifted so far away, so the atmosphere must have been much thicker back then, and they might be able to determine how thick it actually was back in the early days of Mars.
Now, if you want to get an idea of what type of explosive volcano we're talking about, This is actually video footage that's currently on YouTube of Mount Agung in Bali, which decided that it was going to do something pretty spectacular, and it's currently erupting right now, I'm told. Looking at the date stamp, that's 24/05/2019, Friday at 9:23 hours local time. So that gives you an idea of what kind of catastrophic eruption we're talking about. The simple oozing ones, think of Hawaiian shield volcanoes. Think about the housing estates that recently got reconstituted into their component atoms for an oozing lava field. So that just gives you an idea of what kind of explosion we're looking at. Basically, the catastrophic ones, Agung, Krakatoa, gives you the idea. Isn't it fun to put a bit of geology into the chat room?
Did we touch on last week about that Pluto might have a hidden subsurface ocean?
I don't remember if we did.
Okay,
let's go for it.
Let's go for that one. Yeah, it looks like now it's strongly possible in that that heart-shaped feature on Pluto, in one of those lobes might harbor a underground ocean. Let me put that into our chat room here. By studying the material on top of it and analyzing it, the good chance that it could be a cap for some water, and it actually kept it warm enough so that it would still be liquid underneath the ice on the surface of Pluto there.
It sounds like Pluto could be another Europa.
Could be. But I don't think they think it's they don't think it's the whole quote unquote planet, dwarf planet, just under that one particular spot on Pluto they think there's an insulating layer of gas hydrates that can keep the subsurface water from freezing. That's only in part of the moon, not the entire moon. So not like a giant ocean that's under the whole planet, but in just one section of it.
Yeah, we were talking to one of our friends on Comet Watch, Matt Lemon, and it is kind of interesting to think that potentially where we might actually find some form of life, no matter how primitive, could be places like Europa. Because anything that's there will be totally aquatic, and for life as we know it, waiting for someone to yell at me for doing a McCoy, it's a case of we need good old H2O, and we need salt, and we need, well, if you think about it, our blood is as saline as the ocean is, which is why it's quicker, you drown quicker in the oceans than you do in fresh water.
Just a couple minutes left. Let's see. Let me get this one in here. All right. Black holes.
Oh, yes.
Not only in big galaxies, but might also be in some small galaxies, and they might not even be in the center of those small galaxies. That's even more interesting. So they're detecting some areas. I think they're just using regular white light for detecting certain areas in small galaxies, and they got some potential of black holes there, but they found that we're not in the center. Now they've got to get some radio scopes on them and find out if they give off the right type of signal for a black hole, so not in the center of small galaxies.
Well, the thing is, black holes don't always have to be the center of a galaxy. There's postulated that some of them may actually be merely tripping their way through the universe, not attached to a galaxy.
Just passing through. Nothing to see here, folks. Keep moving on.
Yeah.
Nick, I think it's time to get out of here. Want to call us up?
Captain Savvy, this is the away team, ready to beam up Starstorm, myself, and Marty. We're bringing the goods home tonight. Thank you, everybody, for enjoying the show, and we'll see you next week.
Thanks everybody in the chat room tonight. We'll be back next week. Appreciate y'all listening in. Good night, all.
Good night, everyone.
Come on.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM. There I was, doing my thing, and all of a sudden, wham! Astronomy right between the eyes.